Hello, great people! Welcome to our journey into the fascinating world of logical mathematics. In this session, we'll delve into the fundamental building blocks and logical reasoning, statements, and logical connections. What is logical mathematics? Logical mathematics is a branch of mathematics and logic that studies mathematical logic and its applications in other fields. It is closely related to computer science and philosophical logic. Here we have logical statement. What's that? Logical statement is a declarative sentence that is either true or false, but is not both true and false. So I can say that statement is a sentence that we can find the true value of it. Examples of statements. Here I have the true statements and the false statements. The sky is blue. 2 plus 2 equals 4. If yesterday was Wednesday, then today is Thursday. The moon is made of green cheese. 9 minus 3 equals 7. If 5 is odd, then 6 is prime. From those statements, we can check which statement is true and which statement is false. Here I have the examples of non-statements. Question, comments, exclamations, and open sentence aren't statements because they don't assert a true value. Logical connections. Logical connections are symbols or words used to combine simple statements into more complex compound statements. These are like the glue that binds simple statements together. The first is negation. Example, P represents the XT has 5 members. So the negation of P is the XT doesn't have 5 members. It's true that the XT has 5 members, so the negation of it is the XT doesn't have 5 members. The second example, P represents it is not raining, so the negation of P, it is raining. If P is false, the negation of P is true. I can say that this simply flips the truth value of a statement. The second is conjunction. This connects two statements and is only true when both statements are true. Example, it is raining and the streets are wet. P represents it is raining and Q represents the streets are wet. Two statements above are true, so the compound statement is true. But if it's just one statement that is true, then the compound statement is false. The third is disjunction. This connects two statements and is true when at least one of the statements is true or both of the statements are true. Example, she will read a book or she will watch the XT's concert. From the picture, we know that she is reading a book. So, one of the two statements is true, then the compound statement is also true. The fourth is conditional. The statement P implies Q also read if P then Q is true except in the case where P is true then Q is false. Or I can say that it's only false when the first statement is true and the second statement is false. Example, if it rains, then the streets are wet. P represents it rains, then Q represents the streets are wet. From the pictures, we know that P and Q are true, so the compound statement above is true. The fifth is be conditional. The statement P if and only if Q is true precisely in the cases where P and Q are both true or P and Q are both false. Example: she will read a book if and only if she has exam. P represents she will read a book. Q represents she has exam. From the pictures, we know that P and Q are both true, so the compound statement above is true. It means she will read a book if she has exam, but if she doesn't have exam, she won't read a book. The next is truth tables. Truth tables is used to visualize the truth values of compound statements for all possible combinations of truth values of their component statements. Here are the truth tables of 5 logical connections that we have discussed before. We have learned statements, connections, and truth tables, but I still have one thing to be solved. Let's solve it together. Here I have complex compound statement. If it's not raining and the sun is shining, then I will go for a walk. Let's change it into logical expression. P represents it is raining. So it is not raining is represented by negation of P. Q represents the sun is shining. S represents I will go for a walk. And then let's check the truth value by the truth tables. From the truth tables, we know that the complex compound statement above is false or it's not valid because the truth value for all possible truth is in tautology or all true. By understanding these fundamental concepts of logical mathematics, we can analyze and evaluate arguments, solve puzzles, and make informed decisions. As we conclude this session, remember that logical reasoning is not just an academic pursuit, but a practical skill that can enhance your critical thinking and problem-solving abilities. Continue to practice and apply these concepts in your daily life, and you'll be well equipped to navigate the complexities of the world around you. Thank you for joining us on this logical adventure. We hope you found it enlightening and inspiring.